Today we're digging deep, and I mean that literally. We're going to explore one of the biggest challenges in the entire energy industry. How do you make these massive, billion-dollar decisions based on what's happening miles and miles beneath our feet? Well, the answer isn't bigger drills, it's smarter data.
You see, the Earth's subsurface is an incredibly complex place. It's this layered, fractured, and often totally unpredictable world that holds the key to so many of our critical energy resources. For geologists, trying to interpret all these layers is like solving a giant, high-stakes puzzle.
And what a puzzle it is. Get this, a single modern drilling operation can generate over 10 terabytes of data every single day. That is just a flood of information. We're talking seismic waves, pressure readings, rock cuttings, you name it. So the real challenge isn't just collecting the data anymore, it's figuring out how to turn all of that noise into a clear signal. And you do that by building a much, much smarter toolkit. This isn't just about bigger drills or deeper wells these days. No, the real revolution is happening in the data itself, and it's being powered by a new generation of IT solutions that are completely changing how geologists work.
Okay, so first, let's just try to get a handle on the sheer scale of the problem. We are talking about a true data deluge, where even the most experienced geoscientists can find themselves just drowning in clues.
Here's a pretty staggering reality. According to industry studies, some of the most brilliant geoscientists out there spend up to 80% of their time not on analysis, not on discovery, but simply on finding, cleaning, and managing data. Just think about that for a second. That's like spending 4 days of your work week just organizing your desk before you can actually start working. It's wild.
So you have to ask, where's the bottleneck? Why does so much good, valuable data end up getting trapped? Well, the problem isn't the data itself. It's the old, outdated digital infrastructure that's trying to contain it. A huge piece of the problem comes down to what you might call software chaos. A single company might use 5, 10, sometimes even more than 15 different, disconnected applications for their geology and geophysics work. And each one of these programs basically speaks its own language, which creates all these digital silos. Getting them to talk to each other is a massive, time-sucking headache.
And the contrast really couldn't be starker. The old way means you're fighting with legacy IT, data is trapped in all these silos, and you're wrestling with all these inconsistent formats. The new way, though, it's built for collaboration. We're talking cloud-native platforms that integrate everything, automate workflows, and create one single reliable source of truth.
So how do we actually get from that data chaos to real clarity? Well, this is where it gets really interesting, because this brings us to the solution, a powerful new toolkit built right on a foundation of cloud computing and artificial intelligence.
The first, and honestly, the most critical step is moving all of that data to the cloud. This is what breaks down those digital silos. Instead of data being trapped on individual computers, it suddenly becomes accessible in one centralized place. And this doesn't just make it easier to find, it makes it possible to analyze everything all at once. Now, at the heart of this new toolkit is machine learning. And to put it simply, it's a way of teaching computers to do what our human brains do naturally: recognize patterns. The big difference is machines can do it at a scale and a speed that we just can't possibly match, sifting through petabytes of data to find relationships and make predictions. And this has given rise to a whole new class of intelligent tools. I mean, think of something like RadiExplore as a Google for geology that can instantly search through millions of old reports. Or DataRock, which uses AI vision to analyze images of rock cores, a task that used to be painstakingly manual. And then you have platforms like Subsurface AI or OreFox that can spot promising drill targets that a human might have completely missed. They are essentially finding the needle in a massive digital haystack. Let's take one of the most critical jobs, seismic interpretation. A modern survey creates terabytes of data. For a human expert, trying to analyze all this is incredibly slow, it's subjective, and it can easily take months to finish. But here's what AI can do with that exact same data. An algorithm can analyze the raw seismic waves and automatically map out all the different rock types and geological features. What you get is a map just like this one, delivered not in months, but in a matter of days. And ultimately, that's the real power of AI in this field. It's a pattern recognition engine that can just tear through these immense complex data sets and find the critical signals that are hidden in all the noise, turning that raw data into genuine, actionable insight. Okay, so the technology is incredibly impressive, but what does this really mean for the business? How does this new toolkit translate data into winning decisions that affect the bottom line? Well, it leads to a completely new empowered workflow. First, all the data is unified in the cloud. Second, the AI algorithms go to work generating insights and potential scenarios. But, and this is so key, the third step is the human expert. The geologist validates, they interpret, they apply their years of expertise, which allows them to make faster, smarter, and way more confident decisions.
And the returns here are tangible and they are significant. This is really all about de-risking these massive investments. You reduce exploration costs because you're drilling fewer dry holes. You increase resource recovery with much more optimized well placement. And you dramatically speed up the time it takes to get from that initial discovery to actually being profitable.
And if you want to talk about the financial impact, it is staggering. Companies that actually invest in this modern, high-performance IT infrastructure can see a potential return on that investment of up to 400% in less than a year. That is a very powerful incentive to modernize.
So, what does this all mean for the future? Well, it's not about replacing human expertise. It's about supercharging it. And that brings us to maybe the most important takeaway of all. The best tools don't replace geologists. They empower them. By automating all that tedious, time-consuming work of data management, these technologies free up experts to do what they do best, to think, to interpret, and to discover.
Which leaves us with a pretty fascinating final thought. For decades, we've really only been able to interpret a tiny fraction of the data we collect from beneath our feet. So as AI begins to unlock the full potential of that data, revealing the secrets of the subsurface, you have to wonder, what discoveries will we make next?